Hi, my name's Ben. I'm a production manager for Syvecs, and today we're going to be answering a question from a chap on YouTube about back EMF, or EMF in general, which for those that don't know about EMF, it's an electromagnetic field, which in the world of motorsport can be a little bit annoying, to say the least. It can be very difficult to get around, overcome, and avoid. We're going to go over some techniques that we use at Syvecs and which are commonplace in the industry, and use some examples of where you would use those, how you would use those, and essentially why you would use those. EMF. EMF is, as I said, is an electromagnetic field. It is generated by electromagnets. It is generated by high voltages, PWMs, which are on the board, high switching modes of hundreds, sometimes thousands of hertz, and they can be a nightmare. So in essence, how do we avoid them? We avoid them in a number of ways, depending on where they arise. Something like a crank sensor or a cam phase sensor, cam sensor, you know, in boxer engines there's two cam sensors. We would use something like this. So this is a shielded dual core wire that we get from a company called Rayfast. It comes in a white sheath. It is very durable. They actually use these on satellites, and as you'd imagine, in space there is lots of radiation noise, there's all sorts going on, so these are imperative into ensuring your sensors are functioning correctly, they're delivering the right message to the onboard computer, which is, again, something like this. And we will we'll go over how we do that. So with this particular wire, to someone that is first approaching this, it can be a little bit overwhelming. It certainly was for me when I first started using it a long time ago. It is a little bit of a nightmare to work with. There are tools out there that you can buy, particularly for, believe it or not, antennas, antenna wiring, RF stuff, that you can, it will strip the outermost part, the inner core, and then break down through into the actual core for the RF signal wire, which is in the center to help you install it. You know, guys that work in building and construction would come across that, electricians all the time. This stuff is just, I try to find a tool for it. There isn't really one. It's kind of one of those that you have to either spend a very large sum of money to get a tool that will do this. And I'm pretty certain it was about £2 to be able to strip this, or you just do it by hand. I mean, after a while, you get pretty proficient at it. So what we do is I'm going to strip back on the white part, which is here. Then we're going to cut back halfway to where the shielding is itself. And then there's a number of different ways of grounding this. So the next part is, what we want to do is cut this back at the sensor, so that the sensor side, this is going to completely be stripped back all the way down. You're not going to have any shielding there at all. It's good practice to put a little bit of glue line heat shrink on there just to seal it up, so you're not getting any moisture or debris going down. You get like a tornado effect through vibration that will end up going straight down and towards the ECU end or a seal connector end, which you don't want. So you kind of really want to seal that up. So you're going to connect the pins on here. You're then going to put that into the connector. That's the job done at, let's say, the crank sensor. So what do we do at the other end? So you want this as a shield. Again, it's much of a Faraday cage as anything. It will pick up any electromagnetic noise. It will hit this shield, and then where's it going to go? It needs to go to ground, not an analog ground. And that's really important because I've heard of people doing that. It needs to go directly to a chassis ground, or if you can, get it all the way back down to the ground pin on the ECU. That's actually much better. So we're going to take all the way down, and this is what you're going to end up with on a bulkhead connector, for example, or you're going to go all the way back down to the ECU, And then what you're going to do is you're going to get this all the way back, and this is a little bit fiddly. And you're going to create something of a ring around the neck of the insulation on the outside. So you're kind of pushing it back over. This is a little bit messy. Normally it's a little bit more clean than that. If you can, you get the insulation inverted, so it's actually all the way back down. And then what you can get is you can do one or two things. I'm okay with soldering a ground pin or ground wire onto this. Some people don't like doing that. I mean, as long as you treat it properly and it's been soldered correctly, it's not going to be a problem. However, there is a more efficient way of doing this, and that is clamping it. And you can get, like, as I've gone through with in previous videos, you can get something of a clamp that you can crimp straight onto that insulation, or there is another method, which is to pull that outward. It is a bit messier. I don't like doing it like this, but I'm going to show you anyway. Break up the cage, bring it round. I mean, there are more professional ways of doing this, but it's very rare that I end up using this. And you're going to twist that up nice and neat. And you could effectively turn that into, if you're neat enough, into its own wire like so. Then I'd end up trimming that. And crimping a butt connector on here, as I've shown before. And then running a spare wire, another wire out of the butt connector to go to where it's meant to be. I mean, I've seen guys do this in multiple different ways. To be honest with you, I haven't really gone hunting to find out which is the most preferable. I mean, that's pretty up there. But if anybody does know of any other ways of doing that that you could point me to, that would be fantastic. I mean, you guys can help us improve. So we're always up for some constructive feedback. That is how the Faraday cage or the shielded wire works. So that all the way down this wire, you could have all sorts of EMF going on. You could have an alternator right next to this. I mean, it's not, you know, it's not ideal, but it would, to some extent, protect this from any noise whatsoever and clean up your crank signal, or whichever, or the important ones at least. What do I use this on? So I would use this on, as I said before, crank, cam, or both cams, cam phase. I'll also use it on knock, because if your knock is all out and it's noisy, it's going to be difficult for your calibrator to be able to pick up, to be able to adjust it so that it's not triggering false knock readings and stuff like that. Or in the event that they have to pull the gain down, for example, because the noise is so high, you'll end up with a situation where your car could be knocking and the ECU is not aware of the fact that it is doing it. So we want to avoid that as well. So this is why that's important. I have been known to use it for TPS sensors, specifically on the R32, R32, 33 and R34 Skyline. From what I've heard, widespread, they have terrible TPS readings, and they suffer from it from old age. And I've replaced TPS leads on that particular, I think about 3 now, and they've cleaned it right up and produced really consistent fuel tables and everything like that, and the maps have been spot on, generating more power essentially. So that's the shielded cable. What else can we do to prevent EMF? So if this isn't an option and you're working with a OEM harness that, I mean, if you're not so proficient with wiring, then it can be the case that you're not going to be comfortable rebuilding the loom. It just could be a bad loom. You're not sure of where it is or something like that. So how can you avoid it? And, you know, if you're adding wires in or running new wires to replace what is bad, how can you stop yourself from getting yourself in a situation where your sensor readings are all over the place? You want to avoid main power wires. Some of you may have heard of Rev FM. which was a thing back in, I mean, the 90s and early 2000s, when everyone was installing big audio systems in their cars, and they were running, you know, I don't know why, but in some cases, 0 gauge wire from their battery or alternator all the way back to the boot. And they were also running their auxiliary left and right cables from the head unit alongside that cable. If that cable wasn't shielded, you get something that is known, or was known, you know, on the street at least, as Rev FM. It's a whining noise. You could essentially hear the energy being generated by the alternator traveling down the cable and bleeding into the left and right auxiliary cable. That is a good example of what this prevents. And you may have seen power cables or auxiliary cables over the years that had a little cable coming off of them that said that they need to be grounded. And that's exactly what we're talking about here. That's, in a nutshell, what you're trying to avoid. Big cables that are moving large amounts of current, specifically, you know, high current, high voltage. In most cases, in cars, it's about upwards of 12 to 15 volts, and north of, you know, 70 amps in some cases. So you want to be avoiding those. If you can get away from that, run it somewhere else. You know, if there's a troublesome pin, like in a previous video that we did, where they can be a problem if it's not crimped properly, you know, you can get EMF like bleeding through that. The actual installation can be a problem as well. There's so many factors involved. This is a very deep subject. And I mean, if you want to know more about it, there's specifics that you want to know about this subject, please let us know in the comments and we will endeavour to come back. One last point before I go, and that is, you know, how does the ECU deal with EMF as a whole? It can deal with EMF to certain extents, and it's not a miracle worker. If you're going to start exposing some of the sensor leads to extreme environments that aren't necessary, then it's not going to be able to help you. But it's there are two things in place on the ECU that are going to do, you know, one is has a user interface that you can mess around with. The other one is essentially hard architecture on the board that is going to do everything it can to prevent any spikes or anything like that going on. So we have what is known as a snubber diode, or snubber diodes, on the inputs. That's part of the ADC circuit, which is the analog digital converter. We have two diodes that are parallel to one another, and without going into it too much, because I'm sure if somebody wants to know how this works, Ed will go into it very well, because he's somewhat of an RF engineer over the years, is that it will absorb a lot of the spikes and noises, and it's basically a form of buffer that prevents spikes and bad signals from getting to the converter before it's translated into what the processor understands. And I'm kind of going to leave it there because that's a little bit of a deep subject and I fell down a rabbit hole for a few hours on this one. So that, in essence, the ECU will deal with it. And the second part is there is a filter rate that you can apply, which is part of that same circuit in the software, which is known as an input filter. And a lot of our mappers will understand how that works, and it's some ways somewhat like a gain adjuster, which will allow you to see more or less of a signal, but it does reduce your headroom. And again, I'm not going to go into that one too much, but again, if someone wants to know about that, we can go over that in the future. But yes, the ECU will deal with it as much as it can. I mean, it's not a miracle worker, as I say, but it will do what it can do. This is what you should be doing from a practical point of view to be able to avoid bad signals, bad spikes, bad earthing, stuff like that. And yeah, that's pretty much it, really. Thanks very much, everyone, for watching. If there's anything you'd like to know about this subject, and I mean, it is wide, it's broad, please let us know, and we'll see what we can do, come back with an answer and not go too deep into that rabbit hole. Consider liking and subscribing, and we'll see you soon.